Alright, so in this problem, I have 4 to the power of x plus 4 to the power of x plus 3 is equal to 130. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 4 to the power of x plus 3, that's going to equal 4 to the power of x times 4 to the power of 3, which is equal to 130. Now I'm going to factor out 4 to the power of x, so I get 4 to the power of x times 1 plus 4 to the power of 3 is equal to 130. Now 4 to the power of 3, this is equal to 4 times 4 times 4, which is equal to 4 times 4 is 16. 16 times 4 is 64. So now I have 4 to the power of x times 1 plus 64 is equal to 130. Now 1 plus 64 is 65, so I have 4 to the power of x times 65 is equal to 130. Now we obviously want to isolate x here, so I'm going to go ahead and divide both sides by 65. So then these two cancel out, and I'll be left with 4 to the power of x is equal to 130 divided by 65, which is 2. Now to solve this, we can obviously tell that x is going to be less than 1, because if you plug in x for 1, you get 4, just 4 regular. So I'm going to first start by rewriting 4 as 2 squared. And now I have 2 to the power of 2x is equal to 2, meaning 2x equals 1 and x is equal to 1/2. Alright, so in this problem I have 222 to the power of 3x plus 222 to the power of x is equal to 222. So to start, I'm going to rewrite 222 to the power of 3x as 222 to the power of x to the power of 3, because if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So now I have this plus 222 to the power of x is equal to 222. Now I'm going to let 222 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 222, and if I subtract 222 on both sides, these two cancel out, and I get y to the power of 3 plus y minus 222 is equal to 0. Now I'm going to rewrite 222 as 6 times 37. And I'm going to rewrite y as negative 36y plus 37y. So now, from y to the power of 3 minus 36y, I'm going to factor out y, so I get y times y squared minus 36, plus, from 37y minus 6 times 37, I'm going to factor out 37, so I get 37 times y minus 6 is equal to 0. And y squared minus 36, that's going to equal y plus 6 times y minus 6. Now, if I factor out y minus 6, I get y minus 6 times y plus 6 plus 37. And this simplifies to y minus 6 times y squared plus 6y plus 37 is equal to 0. So now this gives me y minus 6 equals 0 and y squared plus 6y plus 37 is equal to 0. So for y minus 6 equals 0, y is equal to 6. And for y squared plus 6y plus 37 equals 0, there's actually no solution, because if you plug this into the quadratic formula, you get the square root of a negative number. So y equals 6 is my only solution for y. And remember how we let 222 to the power of x equal y. This means that 222 to the power of x is equal to 6. If I take the log on both sides, If I have something in the form log a to the power b, I can move b to the front, so it's going to equal b times log a. So I can move x to the front here, and I get x is equal to log 6 over log 222. Alright, so in this problem, I have x to the power of 3 plus x equals 10. So I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now I'm going to rewrite negative 10 as negative 8 minus 2. And negative 8, this is the same thing as negative 2 to the power of 3 minus 2. So now I'm going to change the order real quick. I'm going to rewrite this as x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. And if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this is going to change to x minus 2 times x squared plus 2x plus 2 squared, which is 4. This is equal to 0. Now, this gives me two equations. I have x minus 2 is equal to 0, and I have x squared plus 2x plus 4. And actually before that, remember how we have this plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0. Now I have x minus 2 is equal to 0, and I have x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so that's one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 2, and c is 5. So I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 5, all over 2 times 1. And now this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16 over 2, which is equal to negative 2 plus or minus the square root of 16i over 2, which is negative 2 plus or minus 4i over 2, which is negative 1 plus or minus 2i. So these are my three solutions to this problem.